Alright, so in this video I will cover the Excel input file. So in this first problem, let me zoom in. So in this first problem, we've got project cash flows of negative 165,000, 63,120, 70,800, and 91,080. So if the required return is 12%, we want to know the NPV. So the data is given to you down here below. And to calculate the net present value function, it's equal NPV parentheses D13, comma C14 to C16. So notice that we do not include the year zero cash flow. We end the parentheses and then add C13 on the outside of it, because if you look, what the NPV function does, it starts looking at value sub 1, and value sub 1 that corresponds to the first period, not the 0th period. Okay. If I were to calculate the IRR of this project, you just equal IRR parentheses C13 colon C16. In this example, because you have a cash flow, you just have one change in the sign of the cash flow from negative to positive. That only happens once. You don't need to put in a guess. And note that Excel auto guesses 10% for you, so you don't have to put in that argument. A couple other notes from this here, the NPV, this 0 here, this basically repeats the NPV function, where C19 is the IRR now, comma C14 colon C13 in parentheses plus C13. And what this demonstrates is that if the required return were 16.13%, that does indeed get the NPV to be equal to 0. Over here, there was a profitability index calculated of this equation. So this one is equal to NPV, parentheses D13, the rate, comma C14 to C16, which are those cash flows, in the parentheses, slash, so we divide to calculate profitability index. It's the inflows over the outflows. So then a slash absolute value, parentheses of C13, take the absolute value of it. That way I get a positive number for my index. And that shouldn't be a dollar sign. So I'm going to go home, number. So 1.08, this tells me to accept the project because 16.13 and that I accept it because it's greater than 1. Net present value is positive, so you accept the project. And here IRR, it's greater than the 12%, so we accept the project. Another thing we can do here is look at the NPV profile. So scrolling down here, if you wanted to do this and create this, the discount rate here, we're just doing 0 and then increments of 2. And I included the 16.13% here, which is that IRR number to show you. There it is again, NPV is 0. So if I were to fill this out, the equation is equal NPV, parentheses B23, which is the 0%, comma, the C14 to C16, and then note here, so those are your inflows. You would want to fully anchor that, so you can do F4 on a Windows to do that, or you could type in $C, $14, colon, $C, C16, because we don't want those numbers to change. We just want the interest rate to change, because I'm calculating different NPVs here, plus C, $C, $13. Note, if the discount rate is equal to 0%, we'll see the 60,000 here in a minute again, but all that is just the simple sum of those cash flows. So if I go home and auto sum it, we should get 60,000, and indeed we do. Okay, so that's where that number comes from. And then I bottom right black cross and send that number down. So we have these here. If you want to create the NPV profile that you see here, to do that, so I'll delete it and recreate it. So to do that, highlight your data from B22 through C35 that you've got created. And then we'll go home, or actually we'll insert, recommended chart, and then the first one works. So there's your NPV profile. And we always will pick it when the interest rate gives us answers that have positive NPV. So we'll see anything above that 16.13% we would accept. So as long as the required return is below 16.13%, we'd accept the project. Otherwise, we would reject when we get negative numbers there. So that's the first one. Now over here, we're going to calculate payback period. Multiple ways to do this, so I'll show what's here and then give some other recommendations. Note that there's that $60,000 again, which was the simple sum of this and the NPV of that. So this is the world with no interest. We know it doesn't account for time value money, so it's not that great, but smaller companies and companies in financial distress or with liquidity issues will use this. So we calculate it as follows. The cumulative cash flow that we calculate in cell L13, we just carry over that cash flow in cell K13. I like to go ahead and make that number negative, but in this case we say that's not the case. That's fine. And then now we're getting paid back each period. So this is equal to L13 plus K14. And then with that function, I can bottom right black cross, send that down. So again, that one is L13 plus K14. And then this one, once you send it down, you can see it's L14 plus K15. So I'm taking each cumulative cash flow and adding cash flow to it and sending it down. We stop once we get 0 or a positive number. Another way I like to do it, I'll just do that over here. I like to do it the other way, where I minus that out first, and then I do the equal previous minus the cash flow for that current period, and then send it down, whichever way is fine. As soon as you cross 0 or go from positive to negative, we stop. So we know it's going to be somewhere between years 2 and 3. So my payback to get the final answer, in this case they did equal 2 plus parentheses minus L15 over K16. What I would have done would be say something like equal, we know it's going to be somewhere between 2 and 3. So that final year of the positive cash flow in my case was that positive 2 plus, and then I take the cash flow here in 15 over, the cumulative cash flow there that's left over to get paid back, divided by what amount I receive, and then you get the same answer, 2.34. So it's just however you want to do it. The one in this column calculating it, there that is again equal 2 plus, and I don't like the hard code numbers, but it's okay. Equal 2 plus parentheses minus L15 over K16. And then the way I did it was this equal J15 plus M15 over K16. And then this was another interesting way to do it. So the way they did it here was equal percent rank, parentheses L13 to L16, comma 0, comma 2, in parentheses star J16. So what is this percent rank doing? So this percent rank, it returns the rank of a value in a data set as a percentage of the data set. So here we put in the array of the data. X, we type in 0, we want to know the value for which the rank, you want to know the rank. And then the significance level, this is optional. We put in a 2 here for the percentage. If you omit it, it assumes 3 to 3 decimal places. And then I times that by J16, which J16, that is the last year of the data. And then that got me 2.34. So that's another trick, interesting trick play, so to speak, in terms of getting that answer. Okay. Coming over here is internal rate of return, which we previously calculated, but now noting a couple of things here. So let's say there's that one. That's just IRR. There's another thing in Excel. You can use the modified internal rate of return. So this changes the reinvestment and financing rates. So with the MIRR, it's a more conservative estimator. You get 14.79%. So there's that equation there. And you can pull up the FX to see what it's doing. So it considers both investment and interest on reinvestment of cash. And here, if you don't have different financing finance rates, the interest rate you pay, and reinvestment rates, the rate you receive. Those numbers, you could change those numbers, make them be different, whatever. You can play around with that. Another example here, so looking at this one, this is where we've got cash flows that are different. So for this one, the IRR, what you can do here, I would recommend guessing. So here I'm going to add a guess of negative 99%, and that'll get you the lower IRR. Here, if you guess, they guess 0.42 here, but how would you know that? So just give a high number like 99%, and then that will get your answer. So again, that's just equal IRR parentheses, highlight all the cash flows, and then comma, you put in a guess argument to get that second IRR. How do we know there's going to be potentially a second IRR? Well, because we go from negative to positive, so that's one time, and then it happens again, so there it is a second time. There's potential here for two internal rates of return because the cash flow on the sign on the cash flow changes more than once. It changes twice. Okay. So then coming down here, I can create an NPV profile to see what should I do. Because the question immediately would be, well, which of these IRRs do I pick, or what do I do? It turns out we're going to use NPV at the end of the day to make our decision, because we always want positive NPVs. So in this example, I'll do equal NPV parentheses Z22, comma, $AA, $14, colon, $AA, $16 in parentheses, plus $AA, $13, and then bottom right, black cross, and send that thing down. And then I'll delete this, and then just demonstrate how we get that graph again. So highlight your data, and then insert, recommended charts, and then this time you have to get to the fourth one. For scatter, you could also do a line, but I'll do scatter, and click OK. So there's the answer there, but basically we can see NPV is positive between the 10 and that 40-something%. So as long as the required return is between 10.11 and 42.66%, that'll give us the NPV that's positive, so that's when we would accept the project. If the required return is less than 10.11%, we would reject. If it's greater than 42.66%, we would reject. If it's in between, we accept. In this example, the required return is 15%. We got a positive NPV, so we would accept the project. We would do this thing. Okay. All right, next one up. So this example, two mutually exclusive projects, we're trying to decide which project we would pick and why. So these are our cash flows here. We calculate the IRRs respectively. So there's that box equal IRR AJ13 to AJ15. Here, IRR is AK13 to AK15. The yellow here indicates we choose that one because the project, you always want to pick the project with the highest numbers, both IRR and NPV. So there, the rate of 10%, we would technically accept both projects, but B is better, according to IRR. But NPV tells us, well, calculate an NPV of this, so there's your function for NPV, so equal NPV parentheses AL13, comma, AL14, colon, AJ15 plus AJ13. And then with this particular one, if you decide to fully anchor the rate, and then I could drag that across. And then I shouldn't have done the coloring there. So let me format that one, because this one's NPV there is lower. Whoops. Dollar something. Okay. So there's that function there. So in this one, we're going to pick, if it were just NPV, we would pick A. So now the question becomes, well, which one should we pick? Probably the best thing for us to do would be to graph it. And another consideration would be to consider, well, what's the crossover rate? Okay, so I'm going to demonstrate both of them here. So first, to determine the crossover rate, what you can do, first step would be, we're going to create this. So type equal, I'm just doing this in AM, you can do it kind of wherever. Take the difference in the project cash flows. So minus 500 minus 400. So we get that new project, so to speak. I then will find the IRR of this. This is going to give me the crossover rate, so kind of my decision point. So in this example, if my decision point were 11.8%, then that's the point where it's the crossover or where I would be indifferent. Now, another thing you could do is create an NPV profile of this using different rates and see what would happen here. So what I'm going to do for this one is I'll just type in the following for rate. I'm going to do 0%. I'm going to do 4%. And then I'm going to drag this down, bottom right, black cross. Try to at least. I'll do that just through 20%, just to get an idea. And then I've got A and B here. There is this NPV function. So what I'm going to do, I'm going to just copy this and then I'm going to edit it. There's this one. And then I want the rate to be in the one in cell AI. So AI 21. And then these, I want that to be anchored. I want the $, just $, 14, 15, and 13 fully anchored, because I'm going to drag this across and down. And that should be a $. Drag that across, and hopefully that carries through. Okay, I didn't anchor that correctly. My apologies. So coming back here, AI, let's see, I want to anchor. Let's anchor the AI. And try that one more time. There we go. Okay, so for that one in cell B21, it's equal AI, $AI 21, comma, AK, $14 to AK, $15, parentheses, plus the AK, $13. And then I can highlight both them, bottom right, black cross, send that down. And then I'll highlight all my data here. Insert, recommended chart. And is it going to give me what I want? There we go. I have to scroll down to get what I want. So there's my line chart that I want. And then here we can see A is that solid blue. If you can't see that, let me edit that appropriately. Fill, let's see, not fill, outline. I'm going to dash it so you can really see. So there's the blue dash line. You can see A is above until it hits crossover. And then at B is then the orange solid line. So technically what you would do, you would choose A until you cross over, which we calculate crossover 11.8%. So choose A if the required return is less than 11.8%. And then if it's greater than 11.8%, we would then choose project B. So in this example, because the rate is 10%, we would choose project A, because as we see here, we already calculated, that gives you the highest net present value. So if there's a tiebreaker, NPV is your tiebreaker. But there it is visually for you. And let's see here, this one, this is calculating profitability index again. So there's the data for you there and the rate. So let me scoot that back over. So profitability index, first thing is equal NPV parentheses AR15, which is the rate, comma AQ16 colon AQ20 in parentheses. So that's those positive cash flows from time 1 to 5, slash absolute value of AQ15, which is that negative cash flow in time 0. When you do that, you get 0.9. So that doesn't need to be a currency, it just needs to be a number. And in this case, because the profitability index is less than 1, we would reject this project. So that covers all the practice problems in Excel with the varying calculations demonstrations here. Just kind of going back through real quick, making sure I think I've covered everything I want to say. So yeah, thanks for watching.